Hello everyone, welcome to the Excel tutorial for Experiment 2 Part 2 Spectroscopy. In this video, I'll show you how to use Excel to make two different types of graphs. The first will be a spectrum where we look at wavelength and absorbance data to find a lambda max, and the second will be a calibration graph. So we'll start with the spectral data. This is for looking at absorbance versus wavelength. And so here you can see on the screen I have my wavelength data and I have the corresponding absorbance data. And so what I'll do is I'll plot absorbance versus wavelength, which will help me determine the lambda max. So I'll select both columns of data and then I will go to the Insert tab in Excel and I'll select the scatter plot type of chart. And what I'll do is I'll insert a scatter plot with lines connecting the data. I want smooth lines and markers. And the reason for this is that it allows me to see the shape of the spectrum a little better with those connectors, and then the data points that were collected are also shown as well. We can use this spectrum in the visible region to help us determine the lambda max, which we'll need for our calibration graph in the next sections. The graph that Excel generates is incomplete at this point. We can see that we have a title that corresponds to just one of the column labels. We don't have any axis labels, and the x-axis range isn't great for our data set. In the next steps, I'll show you how to fix that. If you're on a PC, we can fix some of those labeling issues by clicking the plus sign on the upper right corner of the graph and adding whatever chart elements we need. If you're on a Mac, you'll want to click on the graph and then go up to the chart design menu and then go over to the far left to add chart element. And this is where you can find the same things. And this chart design add chart element works on both Macs and PCs, so it's pretty consistent there. The first thing we'll do here is we'll add axis titles. These are the labels for both our X and Y axis. So from the chart elements menu, I will add a primary horizontal and primary vertical, and then I'll label my axes. So my Y axis in this case is the absorbance of the solution. The X axis is the wavelength, and this is given in units of nanometers. So I'll label both of my axes with appropriate units. And then I'll go up to the title of the graph and I'll give it a very descriptive title. For a spectrum, something like absorbance versus wavelength, which is always Y versus X for the title. And I want to label which compound this is for. So in this generic example, I'll just call it compound number 1. But in your experiment, you may want to label it yellow number 5 or blue number 1, depending on which compound you're analyzing. The next thing we'll want to do after we've got our descriptive title is fix that x-axis range so that it's a little more appropriate. So you can click on the x-axis and then double click, and that should bring up a menu to format the x-axis. And so what we want to do is just change the range of data there. And so we'll change it to a range that better fits our data so that we don't have all this empty space. Looking at my graph, it looks like most of my data is in the 400 to 800 nanometer range. So I'll enter 400 nanometers as my minimum bound. Looks like I've still got some extra space, so I can probably tighten that up a little more. So I'll go to 500 to 750 nanometers as my range. And so here my data fits really nicely in the graph window. I have a title, I have axis labels, and so this spectrum is complete. In this next section, I'll show you how to use Excel to generate a Beer's Law calibration graph. In this Excel sheet, I have my concentration for my salicylic acid standards that I used in an experiment in millimolar, and I also have the absorbance at the lambda max. The first thing I'll do is I'll adjust those concentrations and absorbance values to much more reasonable numbers of significant digits. So the next thing I'll do is I'll select both columns of data and then click the Insert menu and go to the Scatter Plot Chart Type and I will choose the scatter plot without line connectors. And I choose this because each of these measurements were done on a separate sample, so they're actually not directly related to each other. The first thing that I'll want to do after generating my graph is I'll want to go ahead and add in those same chart elements that I did in the previous section. So I want to make sure I have axis titles for both my X and Y axis with appropriate labels and units. So in this case, my Y axis is the absorbance, and it's the absorbance at 527 nanometers, which is the lambda max. So I want to make sure to specify that in my axis title. My X axis is the concentration of salicylic acid, and the units of concentration in this case are millimolar. So I'll want to make sure I include the appropriate units as well. The next thing I'll do is I'll edit the auto-generated title to be something much more descriptive. In this case, what I might want to do is something like calibration graph for salicylic acid, absorbance at 527 nanometers versus concentration of salicylic acid. This descriptive title really lets me know what data is here and what the purpose of the graph is. Now that I have all of the appropriate axis titles and labels, I want to add a trend line or a line of best fit. So I'll click on one of my data points to highlight the line. And then if you're on a PC, you can right click and go to add trend line, or you can go to chart design, add chart element, and then trend line and select the linear choice. So now we've got our trend line added, but we need to make sure that we add the equation of that best fit line. So we can go back to add chart element, select more trend line options, and then click on the 3 bars at the top there. And we'll go down to the bottom and we'll click the display equation on chart, and we'll also display our R² value on the chart. So now I have my equation of my best fit line and my R² value, which essentially tells me how good my fit is. And personally, I like to move the best fit line equation a little bit out of the way of the trend line and make it a little bigger so that it's easier to see. So now we have a completed calibration graph. We have a title, we have axis labels, we have our linear scatter plot with no line connectors. We've added our best fit line, and we're displaying the equation of that best fit line on the graph. So this is an example of what a completed, thorough calibration graph should look like. Having any trouble using Excel to make these graphs, please feel free to see any TA in Zoom office hours.